So, we are honored to welcome the two Arnes, Arne Monsholm, CEO of IOOI, and also now since respect distinguished council member of MARSEC-XL, and Arne Styve, the R&D manager of IOOI. Hans Sjåklund stand through, so we have changed the program slightly. So what we will do now is to have a look at the research and innovation in the maritime cluster in also Norway, specifically focusing on simulation and why that is important, and also what kind of stuff is it that they're simulating, because I guess that not all of you are familiar with what these ships actually do and what is there to simulate and so on, because there's a fair amount of stuff that comes in addition to actually navigating and operating the ship. And at the end, we'll have a panel discussion with various representatives discussing these aspects. So, Arne Monsholm first.
Thank you. So what I'm going to do is to focus on the non-technical things first, of what we're doing in the cluster in Norway, and then my colleague Arne will take you through some more technology-oriented stuff. You probably know where Norway is, most of you. We are quite small. We represent something like 0.1% of the population in the world, but we do represent more than 5% of the merchant fleet, and we are the second largest offshore provider, offshore vessel provider in the world, just after the United States. The maritime cluster, that where we come from, we call it the Maritime cluster, and this is the region of Norway where we're located. Now, in this small area, there are something like 14 recognized ship design companies designing ship hulls and different types of vessels. We've got several offshore ship owners, owning anchor handling vessels and supply vessels and multi-purpose vessel construction vessels, and they are all over the world. They have, so Farstad Shipping, as one of the examples, they have 50% of their revenue is from Australia, and another, let's say, 30% is from Brazil. So these companies, they are international, but they are headquartered and owned in this area. There are lots of equipment vendors, and there are 17 shipyards, small shipyards, but highly specialized. Equipment vendors with vessels, with winches, deck machinery, with all kinds of stuff that you need on board a modern vessel. And the revenue has grown since 2002. It has quadrupled several times. And the ambition of the cluster is that the revenue in this area should reach more than 100 billion Norwegian kroner within 2020. And we believe one of the reasons for the success of this cluster is the way that the companies work together. That there is an interplay or interaction between the different companies, and they complement each other, they learn from each other, and it's like they compete when they must, and they collaborate when they can. It's like that kind of attitude, right? So even though they are competitors, many of these companies, they are still able to work together on many fronts. And I think that is a very vital part of the success. Also, the collaboration with an involvement of the research institutions and the universities, I think that is also part of it, with a lot of competency and a lot of bright minds coming together to just develop this the way it should be done. As a simulation company, we like this one because simulation is actually where it all comes together. If you look at these three factors, the technology and the business factors and the human factors, simulation is something that kind of brings it all together, and I will show you some examples of this later on. Simulation used to be, in the beginning, it used to be just to simulate a particular system or a particular device or one particular operation with one kind of single focus. What we have been doing is that we have expanded this to include more people and to have human interaction and human collaboration in the simulation scenarios. What we're doing, so what we have been doing so far is really to focus on vessel crews and how they interact together, deck personnel, engine room personnel, bridge personnel, and simulate operations that involve them. The next step is to lift up to your vision, to not only look at one ship, one vessel, but to look at operations that involve many vessels and many people. And the last stage, where we are not yet there, is to do virtual prototyping, such that you can actually simulate reality even before a ship is being built. You can see how it will operate, you can simulate a lot of stuff even before it's built. That's where we are heading. A little bit about Offshore Simulator Center. We are actually a good example of a company that has been born by the cluster and by initiatives from these companies. And we are focusing, the first initial thing was to focus on anchor handling operations. And for those of you who might not be familiar with offshore operations, in short, the anchor handling operation is the operation to securely fasten one of these floating devices, like the drilling rig, to the seabottom, such that it stays in place while it's doing its operation. And that operation involves the picking up large, very large and heavy anchors from the rig. So you have to maneuver the ship very closely into the rig and pick up the anchor and then deliver it to the sea bottom, maybe 1 or 2 kilometers away, maybe on 1,000 meters, whatever. And then the opposite operation, bringing the anchors back to the rig when it's supposed to be moved to a new location. So that was how it all started, or that was the initial simulation. Then kind of like where that came from, as a kind of a spin-off from being able to simulate anchor handling operations, we also simulate the supply vessel operations, which these operations might not be as dangerous as the anchor handling operations, but still there are lots of coordination and there are lots of things that can happen also within the supply vessel operations. And then the third area where we are focusing is lifting operations. And that is also part of the supply vessel operation, where cargo needs to be lifted from the rig to the supply vessel and vice versa. And also subsea lifting operations with the construction vessels delivering equipment to the sea bottom. So those are the crane simulation types we are focusing on. Our business idea is to get filthy rich on simulating these operations. We want to contribute to improve safety for people on board, and not only by training the bridge personnel, but also to train the deck personnel and the engine room personnel as a team. We're supposed to make our money on simulation and visualization of the demanding offshore operations. That is really how the company was born. But the sad background for the company being formed was really a fatal accident on board one of Farstar Shipping's vessels outside of Brazil in 2003. They decided, or they found, after investigating what happened, they found that this was not caused by mechanical failure, it was caused by human error. And they contacted, at that time, Rolls-Royce Marine, by chance, I think. And then they, again, together, they contacted the University College in Ålesund and asked, can you provide some means of training offshore personnel such that we can avoid accidents like these in the future? And to make a long story short, they found some technology at Maritime in Trondheim, which is a large research institute in Norway. And they formed a company with an ownership of 25% each, that is how it is today. However, first of all, it's good news for me that they don't take my money. If we make money, I'm allowed to keep it in the company for research and development. And also, none of these companies are putting any constraints on who we can collaborate with. So even if Rolls-Royce has a 25% stake in the company, they have absolutely no kind of attachments to that. So we can work with Kongsberg if we need to. We can work with their competitors. There is absolutely no problem there. And we are not sharing any information from other companies with Rolls-Royce. It's just that they have no ownership in the company. Also, the fact that the university is involved here, University College in Ålesund, it makes a lot of sense that the training itself, all the training scenarios, the theory, the training material, the certificates that are, diplomas that are provided after someone has been on training, that is all handled by the university. So that is not a technology thing, that is more a pedagogical thing or training thing. So we are spending a lot of our money on research and development. The blue portion is research and development. The green one is actually goods. When we sell a simulator, there is a lot of hardware, projectors, computers, consoles, all kinds of stuff, and that has a value that we need to buy. A good example of an offshore simulator is the one that we are hoping to install next door here within not too long. Consists of a 360-degree bridge with all the required systems on board. In this case, it actually includes a Kongsberg DP in that bridge. DP means dynamic positioning system. And it consists of deck personnel stations, where the deck personnel, just like a video or PC game, they have to move around on deck and do operations that they are supposed to do in the right sequence, and they have to communicate with the bridge via radio. They have to go to a secure zone when they are supposed to, or safe zone when they are supposed to. They have to act just as if they were on board the vessel. Then also there is an instructor station, which is divided into two. There is one technical portion, which is for the captain or the technical instructor. And there is one portion which is for a human factor, psychology pipeline, such that these two together, they are running the training. One is doing the technical challenges, the weather, the waves, and the current, and all that with alarms, and setting up the scenarios, and all that stuff. And then the other one is looking at body language, how they communicate, how they collaborate, how they perform as a team. And this kind of all comes together in the debriefing room, where in a typical training situation, then half of the group, one shift, is in the simulator, some on the deck, some in the engine room, some on the bridge, and then the other half of the group, they are sitting in the debriefing room and watching, so they can see what is going on in the virtual world in the simulator, and they can see via video cameras that they can control remotely to zoom into either screens or to faces or whatever, and they listen via radio what is happening, via the sound system, so that then they have active role in observing what is going on. I am proud to say that we were the first offshore anchor handling simulator that was approved by DNV as a anchor handling simulator. I'm not sure if we're still the only one, but at least last year we were the only one that was approved by DNV. We are quite small. We started up in 2004, and the first simulator was installed in Ålesund in 2005. But since then, we have delivered quite large installations to Bourbon Offshore in Marseille and in Singapore, anchor handling supply vessel simulators. We have installed what we believe is the biggest offshore simulator center in the world for Farstad Shipping in Perth, Australia, consisting of two 360-degree bridges with, I think it's 6 deck personnel stations, crane simulator, winch simulator, DP training center, engine room simulator, lots of debriefing rooms, all connected together in a fantastic center. Then we provided, of course, also the visual, the simulation part of Rolls-Royce Marine simulators in Ålesund, and some simulators in Singapore, and some minor crane simulators for some of the institutions. As I said, we are moving towards more integrated operations than only the operation focusing on one team, one crew, on one vessel. And that is being allowed by us adding more and more systems into the simulation. So at this stage, we are now able to, and we had a live demo of this in December last year, where we connected 4 different simulators located in different places and all working together in one scenario. And it doesn't really matter from a technology standpoint if one simulator is here in Malta and the other one is in Australia. It is, we're using internet technology to collaborate. I would just like to give you some impression of what we're able to do. We have some in addition to the technology, we have some industry designers that are able to come up with ideas and work with customers on how can we provide a complete new training center to a customer. So we hope to find a customer, maybe in Dubai, to buy one of these, with simulators inside these spheres there, and this was an idea that I chose to leave this picture in the presentation because we had a proposal for a group of customers that wanted a simulator center in connection with a hotel. So we proposed that we make a simulator where you put a sphere with a simulator downstairs and a bar upstairs, and then with 360-degree visualization of what is going on, either in the simulator or maybe from nature somewhere. They didn't buy it, but it was a good idea. This was the vision we had for our new simulator center in Ålesund, and this is a 3D image that was generated last year when we were planning this thing, with a dome hanging from the roof and with our offshore simulator inside. And then you see some crane simulator, winch simulator stuff, small spheres there in the background. This has now turned into reality. So in our new simulator center in Ålesund, we have a quite spectacular set of simulators, not only from a technology standpoint, but also from a visual and aesthetical standpoint. So our new offshore simulator is quite futuristic, I think. It's the crane simulator with the crane cabin and with deck personnel stations, and this is the new bridge with the next generation Rolls-Royce consoles and all that stuff. So that was just a quick introduction to us and what we do. So now I'm happy to let Arne Styve take over and tell you more about technology. Thank you.
Thank you, Arne. Well, my name is also Arne, so we try to keep it simple in our company, not too many names. That's always I'm going to talk a little bit more of the technology side and also more into some of the research and innovations that occur in the cluster where we have our offices. First, a little story. I moved from the Norwegian capital of Oslo to Ålesund in 1999 with my family. At that time, coming to Ålesund with a master's degree in software engineering and more than 10 years experience in defense industry software, from fire detection systems, digital TV systems, and suddenly ending up in the Maritime cluster. Well, I can promise you there wasn't that many software jobs in Ålesund at that time. There was a lot of control and automation systems, PLS systems, but not very much software. The few software companies that were out there had to do with either banking systems or tiny 3-man companies that had figured out some smart application for maybe the furniture industry or something. And at that time also, if you looked at the Maritime cluster, this was how the boats looked like. Traditional vessels with traditional hulls. We find a lot of these around here today, of course. If you look inside the bridges of those vessels, then you get something like this. A bunch of buttons, a bunch of lights, and equipment all over the place. Very neatly organized, and very in accordance to human-machine interaction philosophies, right? Light organs, we call them. And you can imagine how it was. A lot has changed. Over the 10 years, 12 years I've been in the Maritime cluster now in Norway. Since 2005, when I was so lucky to be a part of establishing the Offshore Center. I was at that time an assistant professor at the University College teaching software engineering. Now the cluster looks like this. Oh, sorry, a couple more things. What dominated in 1999? We had automation and control systems all over the place. Meaning Profibuses, for those who know what that is, CAN bus, for those who know what that is, SCADA packages, yes, so some people nodding. For those who didn't know, SCADA packages is sort of like the front-end user interface for any IO device that are 3 stories or 10 stories further below in a vessel. Basically, what SCADA packages do, they create a user interface that says, yes, something went high, something went low, somewhere. And you can make an okay user interface, but not very modern on top of that. And hardly any software. Probably the DP systems on board and the radar systems, but the most software intensive. The rest were made by standard automation control systems. Then, over the 10 years, a lot has changed. This was probably the biggest invention about 5 years ago. Have anyone seen that type of vessel before? No? It's old. It's 5 years old. It's called the Expo, and it's a design made by a company called Maritime, one of the large design companies and also shipbuilders in the region around also. Can anyone see the shape of the boat? Does anyone get any sort of like associations to other vessels you might have seen in the history of ships? I see some Norwegian things, yeah. So that should lead us to Vikings, exactly. So the old Viking ships, if you look at the Viking ships, the boats in the Viking ships, they had quite similar to that. And now it's returning. That's good. 1,000 years later, oh, cool. And it has become a great success. The very first of these vessels was an Arne vessel. It was released or shipped in 2006, I think. Now there are more and more vessels coming with that model. And now the competitors of Offshore also have joined and looked into other ways of making vessels. This is the Rolls-Royce design. They call it the wave piercing. Quite different type of boat compared to the traditional one. And of course we also have SDX OSV, that also designs vessels in the same maritime cluster with a version of the axe, as we call it. It flows through the waves quite drastically. So as you can see on the outside on the vessels, there's a lot of innovation going on now, and it's really fun to be in there, in the middle of it. But also on the inside, on the bridge, there's a lot going on. And I'm going to show you something that was presented in this autumn. It was a conference in Stavanger, wasn't it? Yeah. The Offshore Technology Golden Seas is called. Yeah. This is very futuristic. Again, it's Ulstein. They seem to be very sort of ahead of everyone else. Looking at a completely different way of building integrated bridges, using modern technology like head-up displays, multi-touch input devices, etc., etc. And everything of this is visual now. So I picked a video. It takes 2 minutes, which is the video that Ulstein has on their website, and I'd like to show it to you just to give you an idea of what the thoughts are. So hopefully it should start now. that cool? That is the future of the bridges of vessels. Not tomorrow. It may be very soon. And actually, we are also involved in this project. They are using our simulators to test out the concept, which is also a great way to do use the simulators. Now, let's see, how do we fit in this? So in the year 2012, as I said, software is now coming into the system more and more, instead of the automation control systems. I claim it replacing automation systems. I'm not quite correct, because of course you still have a lot of automation systems at the bottom end of the system, reading inputs, setting outputs, etc. But now software and internet technologies are replacing the sort of middleware of the vessels, much more than they used to be. So you already have redundant Ethernets in the modern systems on vessels, making up an information highway on the vessels. It used to be like that. It used to be the profile buses or CAN buses. And you have more desktop-based software on the bridges, more and more. Less and less of the dials and the needles, and more into touchscreens and monitors. And which really brings us from automation and control to information and decision support systems. And that's a drastic change. And the biggest challenge of that is it brings software to the vessel. And we all know that software has a lot of predefined standards, so that shouldn't be a big problem, should it? Right? So how do we fit in this? Well, we like to look upon ourselves as being sort of like the hub in the technology in the Maritime cluster. As Arne pointed out, we have no restrictions from our owners to have collaborations with any other competitors or Rolls-Royce cluster, which creates sort of like Liberty Island kind of thing in the middle of it, where everyone can feel free to talk to us without having to be afraid of spoiling secrets or the competitors and all that stuff. And we talk regularly to Rolls-Royce, we talk regularly to Bilstein, to SDX, all those three designs vessels. We also have collaborations with Skana and Brunvoll, who produces thrusters and propellers. And of course, on the research and education side, University College is a very good partner to work with. And the Center for Environment in Norway is also an excellent partner to work with. And looking at this from the master side and open source, well, where does MARSEC benefit them here? I mean, if we can get all the companies around in Ocean to look into MARSEC, it will make my day a lot easier, because I have to interface to all their systems. Today I have to use proprietary protocols if the customer comes to say, I want to simulate with the Rolls-Royce bridge. Okay, I either have to invent a new protocol, or I can use some proprietary stuff they have, or we can use some proprietary stuff we have. With the MARSEC, we could have a standard way of interface. And also the simulator that we have will be a perfect test site to see that integration between systems actually does work. Now, for the next 5 minutes, I'm going to turn a little bit to another set of standards. The MARSEC solves the architecture on board, the software architecture, but in the software industry, we still have some challenges. Lack of standards. And I hope you can agree with me with that. We do have a lot of languages, that's good. C#, Java, C++, Python, PHP, Ruby, I don't know the names even. But in my head, well, pardon my French, but that's the same shit you're wrapping in many ways. I mean, it's all the different way of defining a class in object-oriented programming, if you put it really square. I'd like to compare this to a different way. If you want to do some building in your house, I can today go to any DIY store, A, and buy a 2x4. Then I can go to another DIY store and buy another 2x4 from a completely different manufacturer. I bring them home, I buy some nails, use the hammer, and voila, I have a building. And it works. They work together. Nice. Surprise. Try that in software. I want to build a system where I want some calendar functionality, and I think that the Microsoft calendar is really nice, I'll use that. But I want to use the agenda or the list of to-dos from Apple. That should work perfect. I mean, it's already there, isn't it? Sorry guys, sorry Microsoft, no, it doesn't work. That's the daily struggle that we have being software developers in all this. There's no language that rules them all, to put it that way. To put that into the simulator problem, why is this a problem for us? Well, since we are in the hub, we have to work with all sorts of companies. And we also, since we started, decided quite early that we are not going to be experts on hydrodynamic models. We are going to be experts on providing training simulators. So more like a system integrator than algorithm nerd. So let's dig into how a vessel from the drawing board becomes a running model inside the simulator. When we use the model in the simulators, we use what we call a 6 degrees of freedom model. It can move in all sorts of directions, right? That's common knowledge. There's a guy in Trondheim, the Norwegian Technology University, that has developed a set of equations taken from the cybernetics time domain type of mathematics to actually calculate how that vessel will behave in waves and in sea. He's called Ulrike Fossen, by the way, and he's using differential equations. Anyone that has had a university degree of maths know what a differential equation is. I see the students nodding, right? Good. And there's also a well-known way of solving differential equations numerically by using something called the Runge-Kutta 2 form. And excuse those who aren't that deep into maths, but just to show you the craziness of it. I can show these equations to anyone in the world that knows maths. The Chinese guy, Maltese guy, Australian guy, Norwegian guy, and he nods and says, yeah, I understand what you mean. These are differential equations and we solve them on the good stuff. Good stuff. So far, so good. But I can't run the model yet. I can't test it. It's just on paper. It's just theory, right? So, how do I get it to be a running model? Well, that's when you have to pass the technology junction, as I call it. I can't get that model to run before I select the technology first. Now, in Norway, there are 3 major sort of environments that do a lot of theory around hydrodynamic models. We work together with Maritime in Trondheim. We work together with a company called Marine Cybernetics in Trondheim. We work together with Syntec, Fishery and Agriculture, that also produces models. And for places where we can't use any of those 3 models, we have invented our own. Of course, it's made at home. It's much more safe. And the crazy thing is that Maritime guys, well, they use MATLAB, that's fine, C++, it only runs on Windows. CyberC, MATLAB Simulate, it only runs on Windows. The setup guys was a little bit more creative when they made that stuff, so that actually runs on Linux as well, but it's still C++. We, of course, did it the right way. We did it in Java, platform independent. But that doesn't help when we have to interact with all the others, right? That's the crazy thing here. So what are we doing? Well, hi guys. Another time again, we are reinventing the wheel over and over again, as has been pointed out by several other speakers also in the open source. So what is the problem? Well, the problem is when combining models. When we do training in the simulators, we'd love to shop a model from Maritime, shop a model from Syntec, shop a model from Kongsberg if they have a model. I mean, who cares? A model is a model. Put it into a scenario and do a full operation with all the different vessels. Yeah, I wish. Maybe someday in the future. We do that, but we have to struggle with proprietary interfaces and proprietary standards. Now, we are currently working in a research project which is really interesting, together with the University College also, funded by the Norwegian Research Council. It's a 2-year project and it's supposed to end this December, isn't it? I triggered this recent project, and here is the idea. Is it possible, by the use of meta-models and meta-meta-models, and experiences made within model-driven development, to derive a domain-specific language, which is platform-independent and software language-independent, which can implement physical and mathematical runnable models? That's a pretty nice title for a research project, isn't it? Guess what we've done? We made it. No, not quite. But the idea is to try to make the cybernetic guys have a language where they actually understand syntax. I hope I don't step on my toes, but I've always claimed that the cybernetics guys are very seldom good software guys. The software guys are very seldom good cybernetic guys. There are exceptions. But that's sort of in general. And so if you let the cybernetic guys work with terms and phrases that they know from mathematics and physics in a language that you can run, that would be a much better idea, instead of teaching Java, which is not very useful. So why is this important? Well, models are becoming more and more used. DP system, dynamic positioning systems. One of the core things in a DP system is a simulated model of the vessel that it is controlling, right? So there is this tiny little mathematical model inside the DP calculating, I wonder if I do this and this, then I think the vessel should do like this. Let's try it on the real vessel. So you already have a model inside the DP system. There are talks more and more about model predictive control systems, i.e. using simulation models in control systems to do an analysis like, what if I do like this, what would be the consequences, prior to doing the action. There are more and more simulation taking part as part of product design, which we have also been part of. And ship designers, you know what the wet dreams of the ship designers are? They sit there with a wonderful 3D tool, they can create a wonderful vessel with a 3D design tool. They haven't got a clue how this will operate until they actually build it in the shipyard. They can do some pre-analysis of it and stuff, but they can't actually put it to a virtual sea, test it and demonstrate it to the user or the customer prior to start building it. Well, if we had models that we could move between, then we could give the ship designers, okay, you're going to use propellers from Brunel, thrusters from Scala, engines from so and so. Here is the black box with the mathematical model describing how this would behave. Put it in the vessel, put it on the virtual sea, sail away. And you can actually do a full anchor handling operation with the yet to become new vessel. That's the wet dream of the vessel designers. Those who know, you know. So reuse of models is really what's driving this initiative from us. We have to be able to reuse models. And that means you can't write the models in C++ or in C# or in Java. It has to be in something else. I don't know. What have we achieved so far? We stumbled across a language that I'm sure some of you guys have heard about, Modelica. The car industry in Europe and also in Sweden have already defined a language to describe mathematical and physical behavior in an open source way. And there are about 20 different tools, MATLAB kind of tools, that support this language, which is really good. And Modelica does actually cover a lot of what we are searching for. Now what we are looking into now is it possible to describe this language using a meta model? Now this is very abstract, I know. For those guys of you who have done a little bit of modeling software, a meta model is the model you do have to describe the model. UML, for you guys that have done software for a while, there is a meta model describing how UML is. So if you can start to combine languages from different problem domains, then we are talking. So that's the result so far, and with that really abstract end, I'd like to point the focus back to our hub again. This really nice dome we have, Arne didn't mention it, but there's really two floors in that dome. There's a bridge at the top, but on the lower level here, it's an open area. It's just an open floor, but it has power outlets and Ethernet contacts all around it. That's our gathering point. That's where we should drag SKAs, Kongsberg, Rolls-Royce in and try out the new dimensions, the new ideas, the new crazy concept they come up with. Put them in the simulator, run a full-fledged operation, put a captain in the chair, and see, does this really work? Then you have the real hub that might work. And that's why we're really pleased to learn that you are considering to establish your office, Norwegian office, in the exact same building as we are. And this is very close to University College also. So we have a really nice campus now in also. So with those few words, I'd like to thank you for your attention. Hope you found it interesting. Thank you very much.